Good afternoon, everybody. Carbone 4 and Bertin Energy Environnement are very pleased to welcome you for our webinar on the maritime sector decarbonization. We are today 4 of us for our discussion. I am Stéphane Amand. I am Senior Manager at Carbone 4, and for 2 years now, I'm the leader of the mobility practice.
I'm Jean-Pierre Husson from Bertin Technology. I'm a consultant in technology management, and this deals with R&D, with technology marketing, and also to support technology innovation and roadmaps.
Hello, I'm Clément Ramos. I'm leading the strategy practice at Carbone 4, and I contributed to the note that is on which this webinar is based with Stéphane and Jean-Pierre.
Hello, I'm Aloïse Dulac, a consultant at Carbone 4 and member of the mobility practice.
Just to begin with a few words about our two companies, Carbone 4 and Bertin. Carbone 4 is a leading independent consulting based in Paris, counting nearly 50 consultants. We are convinced that anticipating the challenges related to climate change is the best option for companies, and our team brings strong analytical and field competencies to help private and public actors transition to a low carbon and climate resilient economy. Our approach is based on 4 pillars: assess, anticipate, act, and promote. And Carbone 4 was created in 2007, and since then we carried out more than 1,300 missions in all sectors of economy for more than 500 clients. Carbone 4 basically deals with 2 kinds of needs. The first one consists of assessing the impact of an organization on climate with the ultimate goal of contributing to carbon neutrality. And the second one consists of assessing the impact of climate on an organization, both in terms of physical impacts, but also transition risks and opportunities. As already said, our clients are spread among all sectors of the economy, including large corporations and also startups. In particular, we intervene in the sectors of energy, construction and building, agriculture and retail, ICT, transport, and finance. We have an international scale and have carried out missions on all continents. Our ability to work with foreign counterparts is facilitated by a wide variety of nationalities within Carbone 4.
Bertin Technologies is a company specialized in technology development and services. We develop, produce, and market cutting-edge systems and instruments. We provide consulting and engineering services, and we promote cyber technologies. We have a long track record of innovation, starting with the founding of the company by Jean Bertin in 1956. There is an outstanding project, which some of you may know as the Aerotrain. It was a kind of a flying train on air cushion. Then we participated in major programs of technology developments, nuclear plant, space, biotechnology. And after the acquisition 10 years ago by the CNIM group, we have a more integrated activities with CNIM, and we continued our development in several sectors, including defense and security, including biotechnology, and more specifically also energy. And I would like to make a focus on Enerbird, or last realization, which is a system for energy management. It will optimize management of hybrid power plant. Hybrid means with renewable technologies. And of course, this is linked for optimization to energy storage, one way or another, batteries or hydrogen. More specifically, our department named Bertin Energy and Environment is supporting the energy transition through three main activities. Innovation, that means evaluating technological innovations in the field of energy and help to bring them at industrial maturity. It goes also with assessing security regarding environment, ensuring that systems are operating and safe, and particularly industrial sites. And broadly speaking, we are in the positive energy mood, trying to develop energy positive systems for territories such as islands, and more generally, autonomous and smart energy systems. Many companies trust us, large companies, SMEs, and you can see a short list here below.
Okay, now for the remainder of the presentation, we are going to have two main parts. The first one on the key messages from our publication on the maritime industry. And of course, we will devote a large piece of time for your questions and answers. Just for your information, if you are not familiar with webinars, you just have to write your questions in the chat space of GoToWebinar, sorry, during the presentation. But please don't activate your microphones for better comfort for everybody. And we will answer the questions. We'll try to answer the questions, as many as we can, at the end of the webinar. So our focus today is to know if the maritime sector is sailing towards decarbonization or not. Indeed, the maritime sector has been left out for a long time on climate change discussions, and things begin to change. IMO, the International Maritime Organization, and some big actors of the sector are now showing willingness to act. But what is really the situation? Will technology be the only lifeline? Does the fight against climate change come together with the issue of local air pollution? Let's start with a focus on IMO strategy. IMO stands for International Maritime Organization, of course. The maritime industry is responsible for around 1,000 million tons of CO2. That is around 3% of man-made CO2 emissions, and it plans to halve the emissions generated by international traffic by 2050 in relation to 2008 levels. This rounded figure, 1,000 million tons, corresponds to the same level of emissions generated by Germany, and is more than the combined emissions of France and the UK. Therefore, it is absolutely vital that the maritime sector contributes to reducing CO2 emissions, particularly as growth forecasts suggest that these emissions will rise significantly unless drastic measures are taken. The sector notably plans, via the IMO, to encourage the introduction of various measures designed to reduce emissions, including improving energy efficiency and using alternative fuels. Both types of initiatives represent very significant theoretical potential, but actions, of course, always speak much louder than words. Indeed, since spring 2018, several meetings and committees have taken place within the IMO, but the results of discussions fell short of these expectations and are far more restrained and less committal than the grand statements of 2018. There is no clear mitigation roadmap at this stage, and for instance, even though it can be criticized on many aspects, the aviation industry is making faster and more concrete progress in this respect than the maritime industry. There are three types of measures that can be implemented in order to achieve this long-term goal of halving emissions. The first one is energy sobriety, the second one is energy efficiency, and the third one, decarbonized energy. The first one, energy sobriety, involves reducing the need at the source, which in the case of the maritime transport industry would mean reducing or controlling flows of traffic. We'll talk about this later in the webinar. Regardless of the sources and experts, the one common finding is that there are significant savings to be made from improving energy efficiency, cutting demand by up to 50 to 67% by 2050 with respect to business as usual. At the moment, two major standards were adopted by IMO since 2011, the Energy Efficiency Design Index for new ships and the Ship Energy Efficiency Management Plan for ships currently in service. These both instruments are clearly insufficient to put the sector on track to meet the 2-degree goal. Here on the right, energy efficiency levels are represented, such as in enhancing the performance of engines and propellers, designing more hydrodynamical hulls, optimizing loads and routes, coming back to wind-assisted propulsion under different forms, and finally, a number of speed reduction measures are also being encouraged by France, but also by some major companies operating in the sector. It would appear then that the future of the maritime industry may partly find its solutions into the past. Anyway, however advanced it might become, energy efficiency alone will not put the maritime sector on track to achieve the 2-degree target. We will need decarbonized alternative energy sources to replace oil-based fuel like HFO and diesel. Here on the left, the main alternative energy sources are represented. First, hydrogen and ammonia, which can mainly be used with a fuel cell to generate electricity. It should also be noted that these two molecules do not generate any CO2 emissions in their use phase, but they may cause a lot of emissions further upstream, depending on how they are produced. Biomass-based biofuels or power-to-liquids synthetic fuels which can be produced from various feedstocks using a number of different processes, and also electricity stored in batteries. We'll not discuss the direct use of ammonia in high-temperature fuel cells or the use of hydrogen and ammonia as fuels for internal combustion engines, since these solutions seem much less credible today. These new energy carriers all have their own benefits and drawbacks, which we have summarized here in the charts here based on the following criteria. The potential in the sense of the availability of the resource, maturity in terms of both technical and industrial maturity, savings in terms of GHG emissions, sustainability, that is the overall societal and environmental impact regardless of the climate issue, and the estimated financial cost by 2030. These representations are also based on the assumption that the electricity used is decarbonized. The dotted lines in the first two diagrams represent favorable cases stemming from the use of raw materials that have been produced with little or no climate impact in terms of land use change. So FA and FT are two different processes for biofuel production, most often based on different feedstocks. FA stands for hydroprocessed esters and fatty acids. They're also called HVO for hydrotreated vegetable oils. They are mature and on an industrial and technological plan, but they can present some limits in terms of potential. Main feedstocks are oilseed crops, algae, cooking oil, or animal fats. Depending on the feedstock and on the process, they can exhibit very different GHG benefits. A bad example is palm oil causing deforestation, for instance, whereas corn oil or pennycress are rather good. Fischer-Tropsch type biofuels are less industrially mature and in general more costly to produce, but they present better sustainability characteristics. The feedstocks are very versatile, using waste, woody biomass, straw, switchgrass, etc. If well managed to obtain a correct yield during the transformation, the GHG benefits become real, up to minus 80% versus conventional fuel oil. PTL stands for power to liquids fuels. It consists in converting water and CO2 into fuels, thanks to the combination of an electrolysis and a Fischer-Tropsch process. The fundamental technological building blocks are electrolysis of water and chemical fuel synthesis, in which hydrogen is reacted with the carbon from carbon dioxide to produce more complex hydrocarbons. In contrast with most of biofuel-derived fuels, power-to-liquids present significant advantages: limited sustainability risks, low land footprint, virtually unlimited potential, and very low CO2 emissions if carbon-free electricity. The issue about this pathway is more about its technological and industrial maturity, and above all, its production cost, roughly 5 to 6 times more expensive than conventional fuels. The pathway of electricity stored in batteries presents some clear advantages in terms of maturity, potential, and GHG benefits, assuming the power is low carbon. In the midterm, storage prices should even become very competitive. But of course, it suffers from known sustainability drawbacks, such as the impact on metal resources and the extraction conditions of these metals. Another issue is the mass and volume of embedded batteries, which can set some operational constraints for ship owners. Hydrogen is much presented today as the perfect energy carrier for ships in a low carbon perspective when combined with a fuel cell to produce electricity on board. Indeed, if produced with a low carbon process, notably through electrolysis of water, one can expect significant GHG benefits together with low sustainability issues and a high potential of production. However, there are still some question marks in terms of maturity, both industrial and technological, and final price for the operator. For long-distance trips, its storage on board would be under cryogenic conditions, which is still a challenge and needs to be improved. At last, another issue is the high volume needed for the storage of hydrogen, even under its liquid form. It can be the rationale for a no-go for some operations. Last but not least, ammonia is a means of transporting hydrogen under a more convenient form, since it requires less volume and the storage temperature is higher. A complementary conversion step is needed on board to shift from ammonia to hydrogen and then produce electricity, which degrades a little the overall energy efficiency of the process. Furthermore, ammonia has also to be produced with very few GHG emissions upstream. For information, some research is carried out to design fuel cells accepting ammonia directly instead of hydrogen for the production of electricity. Clearly, as you can see on these different charts, there is no silver bullet, which is why the various players in the industry have very different perceptions of the speed at which these new forms of energy will be implemented within the global maritime fleet over the course of the coming decades. So it is very difficult to predict what our future technological choices will be. Anyway, there are nevertheless a number of issues on which there is a consensus. First, electric battery propulsion will be used exclusively for small ships traveling short distances, typically for inter-island passenger transport. Hydrogen used to power fuel cells is also likely to be reserved for this type of ship and activity, even though it could potentially also be used for traveling greater distances owing to the high energy density of hydrogen. Alternative technologies such as biofuels and synthetic fuels will need to be adopted for long-distance journeys and larger ships. What about LNG in this context? Its current development to replace heavy fuel oil shows this solution is particularly popular at the moment. It is indeed an off-the-shelf solution and one that will help to deal with the issue of local air pollution in ports and areas of heavy traffic. We'll talk about this just after. However appealing it is, LNG unfortunately contributes little, if anything at all, to the war on climate change for two main reasons. The first is obvious given that this is a fossil energy carrier. As such, it offers little reductions of GHG emissions in relation to petroleum-based fuels. The figure of -20% is often quoted based on industrial data taken from test bench measurements. But feedbacks from initial studies performed on the dual fuel ships operating in Northern Europe tend to moderate this figure. The very most we could hope for would be a saving of around 10 to 15% at the operational stage, assuming, of course, that methane leaks are kept under control. This is, of course, largely insufficient, and LNG cannot therefore be considered a suitable form of energy to meet the decarbonization targets on the long term. This being said, waiting for the other alternatives to be available on the energy market, LNG can, of course, play a transitional role. But this brings us to the second reason for which we decline to acknowledge LNG as part of the alternative energy mix for decarbonization. If we place too much emphasis today on this energy over the next decade, we come with a risk of the GHG emissions of the corresponding ships being locked for a period of 20 to 30 years, thus making it impossible to reduce emissions to the required level.
Okay, we talked so far in terms of climate change on the global approach. Now focus on the question of air quality, and especially in local areas with heavy maritime traffic, and in particular in harbors. Of course, pollutant emissions impact directly air quality and directly the exposition of human beings on this air, on this atmosphere, with medical effects, and that trigger fully actions to reduce the emissions, meaning that it's kind of a virtuous cycle that is setting up. The most spectacular on this is the decisions by IMO, International Maritime Organization, on SOx emission, or sulfur contained of emissions. As everybody knows, so far, sulfur in fuel in heavy fuel used by ships was 3.5%, and it has to decrease to 0.5% by 1st January next year. And even in harbors, there are a lot of regulations requiring 0.1% on sulfur emission. Various solutions are applied to reach this goal, and now it is one really illustrative way of coordinated actions to control emissions. Now, SOx are not the only pollutant. We can say there are nitrogen oxides, there are particles, and epidemic studies shows that cancers of human airways and also nervous system are higher for people living close to heavy traffic area, and in particular harbors. So now, having said that, of course, emission results from all sectors of human activities, from housing, heating, from industry, of course, from agriculture, and naturally from transportation, and in particular, maritime transportation. Now, the air quality that close to harbor people are inspiring depends on many factors, and it's a mix of all these sources. It depends on weather condition, of course, it depends on distance from the sources, the topography, maybe some external pollution, and the complexity of atmospheric chemical reactions. So at the end of the day, one way where locally there is a way to act is really in harbors, while boats are on desk, and when you can connect them electrically to onshore grid. The idea there is that they will cut their auxiliary engines to produce the electricity they need on board, and thus reducing drastically their emissions. The most emitting ships, if we may say so, are passenger ships. Passenger ships can use as many as 1 to 10 megawatts for accommodation and catering on board. And of course, this huge amount of power required by those ships are emitting a lot of pollutants, and connecting them electrically on offshore grid is satisfactory for air quality. Now, if we are relocating the pollution emissions some miles away, the overall balance is not satisfactory. That's where renewable energy comes into action. Renewable energies can be either, of course, PV, they can be they can be any hydrogen or any sources of decarbonized sources that we talked about before. The question is also to manage the intermittence of this renewable energy with also the intermittence of the maritime traffic in the harbor. And to do that, storage has to be installed. There are several ways of storing energies. Of course, there are batteries. There is also hydrogen, can be also heat, and all that requires to be managed in order to have an optimization of the energy balance every time. This is what we call this smart grid harbor approach, where an energy management system will optimize every day, every hour, and all along the year, the energy balance locally. So the good news is that this approach is similar to what we are aiming to do for the global reduction of the impact of the maritime transportation. And that means we have a kind of a converging approach between the global approach to climate change and this air quality locally, in particular in harbors.
Okay, thank you, Jean-Pierre. Now let's talk the taboo topic of growth. The IMO anticipates growth of 50 to 250% in transport flows by 2050, based on various socio-economic assumptions. Needless to say, these different rates of growth will have a strong impact on efforts to improve energy efficiency and the proportion of decarbonized energy used. In other words, the more intense the growth of the sector in absolute terms, and the harder it is to achieve the 2-degree targets, which may even be impossible at a certain stage. This raises the issue of controlled growth. It is vital that we break the taboo surrounding this issue, since international awareness is crucial if we are to find an appropriate response to the problem. Never in its recent history has humanity had to ask itself this sort of question, always focusing instead on ways to expand. It is vital now, however, that we look at the issue of regulating volumes with the aim of achieving 2 goals. The first of these being decarbonization, the second being to ensure fairness between the players involved. There is no on-the-shelf easy solution for that, for sure, but we definitely have to identify them. If we are to analyze the current situation, it clearly appears that contradictory interests are slowing the movement towards transition. Progress is really slow. The difficulties faced by the IMO in speeding up decision-making and pushing for concrete action are real today. While the need for reducing the GHG emission is urgent, IMO is still busy in defining a procedure for evaluating the different measures envisaged. this situation is quite dramatic. This slow pace results from the inability of states and some of the industry players to agree and speak with one voice, as aviation is able to do, for instance. The different parts of the IMO have differing views on the measures to be adopted, on the rhythm of adoption, and even on the ambition to be carried. The pressure of the NGOs is insufficient and does not make the weight in front of the states, the investors, and the major industrial actors of the sector. That said, many actors in the industry itself push to see evidence or more proactive commitment. As an example, the financial sphere is starting to take action, with 11 major banks funding the construction of merchant ships set to start taking environmental criteria into account in their investment decisions. They have all signed up to a program known as the Poseidon Principles. Doing so, they commit to achieve the decarbonization targets outlined by the IMO. Moreover, the IMO received a letter signed by over 100 maritime companies and environmental organizations last April, requesting that an average speed limit for container ships be introduced, along with an absolute speed limit for all other types of ship. To summarize and conclude, only joint pressure from players in the financial sector, public authorities, and exemplary behavior from some leading companies will force the IMO to accelerate the pace and immediately take the appropriate steps for real decarbonization of the maritime sector. In the meantime, actors in the sector, from ship builders to ship owners, will clearly benefit strategically from preparing for the transition right here and now. Indeed, the longer it takes to engage, the more they will undergo and fail to adapt. Now we are going to enter the second part of the session, trying to answer your question. So don't hesitate, please write your question in the chat and we are going to answer them or try to do this. Thanks. Okay. Okay, so I propose just to wait for a few seconds so that there are several questions and we'll try to answer it in the correct order. Okay. Okay. There is maybe a first question that could interest anybody. We are asked why we say that aviation is getting faster than the maritime industry. This is a very easy answer. Actually, the major and big difference between both sectors is that aviation speaks with one voice from the OEMs, from the manufacturers, from the airlines, the airports, any important type of company in the value chain of aviation has the same speech regarding transition, low carbon transition, and pushes for the same roadmap. So in that sense, this is clear that aviation is ahead. But of course, they have to prove that these words, or behind these words, there are some actions. And at the moment, there are a lot of energy efficiency measures and also on market-based mechanisms measures known as CORSIA. This is clearly not sufficient to meet the 2-degree objective, but this is ahead of what the maritime sector is at the moment. Another question about the LNG. Can you explain a bit more on LNG, how you see its roles? That's true that we didn't come into detail about LNG. LNG is for us clearly a transitional energy to move to a low carbon economy. This can be the major energy to support a low carbon maritime industry because it doesn't offer enough GHG reductions compared with HFO or marine diesel. So LNG can play a very important role for pollution aspects and air quality, but the risk if we develop LNG at a very rapid pace and if it spreads all over the fleet is that ship owners, for instance, will try to keep them as long as possible to amortize their investments, maybe 20, 30 years. And during this period of time, these boats will emit as many GHG emissions as today, or almost as many. And so we will take still more delay to reduce emissions, and we can't afford to wait to reduce emissions. That's why we say LNG must stay a transitional energy for just a few years, maybe 10 years, not more. And then we have to shift to much more decarbonized energy vectors, energy carriers for maritime.
May I just comment a little bit on that also? Well, I fully agree, of course, with what you said, Stefan, but locally, the impact of LNG is very interesting because obviously it is a low, if any, sulfur oil, and there is also limited emissions of particles and limited emissions of nitrogen oxide. So here it's an example where the decarbonization objective is not completely online with the air quality objective.
So thank you. There are a lot of questions, and I fear that we won't be able to answer all of them. There are some different questions that point to the same issue. In fact, what should be the respective roles of governments and companies? Should governments take the lead or companies take the lead? There is the example of Maersk or in France CMA, CGM, which have made announcements and quite ambitious announcements for low carbon transition. But of course, the experience proves in other sectors that this is a combination of more stringent regulations and proactivism from companies, which is the best solution to move forward. And if you just hope for companies to take fast action without any more further constraints set by the regulator, this is probably not a good idea. So we think that governments, and so they have to play a role in the IMO, of course. Governments have to work hard come together to agreements and to set up more stringent regulations, and companies and big, especially large companies, which have a kind of duty to give the example for other companies, have to take initiatives and to lead the way, to encourage as well regulators to take courageous decisions. Maybe a question. I don't know if you have the answer, Jean-Pierre. The maritime industry transport is responsible for about 1,000 million tons of CO2, and the question is, what about the percentage of these emissions in harbors? I don't really know. Do you have?
Yeah, well, we have order of magnitudes because it's very difficult to measure the origin or to assess the origin of the pollutants. If you take the example of Marseille in south of France, you have a combination of many sources. You have, of course, the harbor, but the harbor means not only the boats, the ships, but also the trucks that are coming in and out of the harbor. You have highways with, again, a lot of trucks and cars, and you have also the airport, which is not very far away. So now, when you combine all that, people responsible for assessing the air quality are very dubious on who is responsible for what pollutions, except for sulfur, because almost only maritime activities or ships as themselves are emitting sulfur. For the rest of the pollutants, it's difficult to say. Approximation were proposed by AirPACA, which is the monitoring institute for the air quality in Marseille, but take those figures really with caution, because they have only 1 or 2 measurement points inside the city of Marseille, and they say that the harbor itself is probably responsible for between 5 and 10% of the pollutant that they measured. It's a complex, really, assessment, and there have been a lot of talks in the recent months on that. And Marseille is one of the leading harbors in France to implement the electrical connection to the for different ships. Okay,
thank you. We have many questions. So, a question may be about the speeding limit, the speed limit measures which could be adopted. So far, we know that France is supporting this measure. Some companies are supporting it, but there are some rebound effects that are linked to speed limits, because if ships are traveling slower, it means that for a given amount of freight, you need to put more ships on the sea. So it's not necessarily less carbon intensive. It has to be checked, because of course, for a given boat, if you reduce the speed for maybe 20%, you can save up to 40% of emissions. So that is very significant. I will say a word about carbon offsetting measures, but just before, maybe I saw something about the sulfur. You could maybe, Jean-Pierre, answer this question. How would the maritime industry meet the target of less sulfur in fuels?
Okay, well, that's really a question to be asked to the oil company. It's a question of refinery and of treatment of the oil, of the crude oil. Now, there are alternative solutions which are what is called the scrubbers. It's a kind of a shower, if you want, that washes the the smokes from the ships and capture the sulfur oxide in the water. It is also, let's say, a little bit like the LNG is a transitory solution, because the sulfur oxides that you are not emitting into the atmosphere, you are drawing them to the sea, down to the water, and therefore it's really something which meets the requirement for atmospheric pollutions, but doesn't meet the requirements for reducing the let's say overall sulfur emission. Therefore, well, I'm not entitled to answer on what the oil companies are really aiming to do, but of course, it's a question of cost at the end of the day, of cost, sorry, at the end of the day, and well, refinery are really able to make low sulfur oil. The oil you are using in your car, if it's a diesel car, is 0.00 something sulfur, so it's achievable.
I would like to address this question. Which fuel do you see today as the most likely to be used widely in the future? As I said, clearly this is a very tough question, because it depends on the progress that will be made for each of the pathway, either for hydrogen, for ammonia, for batteries, for biomass derived fuels, and so on. So it will depend also on geographies, on the kind of transport that the companies perform. If it is short distance or long distance, if you have wind or no wind on your maritime roads, and so on. So I'm sorry that I can't give you this answer. I don't have the answer. I think that it will be very very versatile, and probably that all technologies have to be developed to find their own rationale for given usage. Which one?
There is a remark that on dual fuel that they can be even worse in terms of HFO than due to methane slip. That exactly what we have said in the presentation. The return of experiment from ferries, in particular in the Northern Europe, shows that using LNG can be even worse than using heavy fuel oils with respect to greenhouse gases. So we fully agree with this remark.
There's a question about the fact that is the fatal hydrogen a green fuel? I don't think so. If what you call fatal hydrogen is the hydrogen produced in refineries, for instance, and or in the chemical industry, this is probably not a green fuel, because its carbon content is probably very high. I said that I would give you some insight on market-based measures. Market-based measures, or the technical word to talk about carbon offsets. And carbon offsets are more and more often claimed by companies from all sectors, not only maritime sectors, but all sectors, to try to become neutral. And of course, this is a dangerous game for many reasons that would be very long to develop here in just 10 minutes. But I would like just to say that when a company wants to work on the carbon neutrality, it has to take a certain number of measures that must go much further further than just offsetting some residual emissions. For instance, in a 2-degree world, such as described in many scenarios like the ones of the International Energy Agency, for instance, a 2-degree world can't offer offsets for sectors. All reductions and all carbon sinks have to be reserved for reducing the emissions from agriculture and forestry and cannot be exchanged for other sectors, which themselves have to make huge reductions in absolute terms. So if a company just decides to offset, it is clearly not enough to become neutral, because the first thing to do when you want to become neutral, the priority is to reduce in absolute term and not just compensating. A few words on ammonia. There's another issue with ammonia I didn't talk about. It's toxicity. That's right, that ammonia is a toxic product. So there's a question on this. Anyway, if ammonia is used, so there's toxicity and also, corrosion, power of corrosion. But if ammonia is used for conversion into hydrogen and not as a fuel to be burned in an internal combustion engine, then the question of corrosion is not as acute as for a fuel. So it doesn't mean that it is very easy to implement, of course, but it is probably not a reason to stop the development of ammonia. I could say a few words on wind solutions, wind assistance solutions. There are many of them. You may have some kites, some even some boats today with no other propulsion than with sails. And the question is it mature enough? I would say that some of the technologies are mature. They are already tested on some routes in Northern Atlantic or in Northern Europe. And this is some routes where you have quite regular winds, so this is well adapted for this, and reductions of consumption are quite spectacular, between around 20%, and this is really good. But of course, on some other routes, for instance, the ones coming from Asia to Middle East and then to Europe, where you have less regular winds, these kind of solutions are probably not well adapted. You want to say something, Jean-Pierre?
Yeah, well, yes, I would say that in terms of maturity, we can see several projects that are aiming at bringing those technologies to an industrial stage, and this in 5 years from now should be the case with mature technologies used on several ships.
Okay. I have a question to know if the green fuel, I guess that what is called green fuel is biofuels or synthetic fuels. The green fuel could cover the need of shipping in 2050. Okay. As I said, it depends on what the traffic will look like in 2050. It is 3 times the current traffic, or if it is the same, the issue is not the same. The magnitude of the issue is not the same. Theoretically, if it is hydrogen or synthetic fuels, there is no real potential limit for production. But the question is more about the economy of these fuels, which probably will be more expensive for a number of years. So I would say that if you consider green fuel only as biomass fuels, yes, you will have some problem of potential, and the resource won't be sufficient to cover all the needs, especially since other transport modes like aviation or even road transport will need some of the green fuel market.
Projections, there is a kind of consensus, but on the fact that biofuels could represent something like 30% of the consumption for the maritime sector, but it has to be cautious on these figures.
Okay. What about the bridge from LNG to biomethane for shipping? Yes, this is a good question, because of course, if you shift from fossil natural gas to biomethane for LNG, then you get rid of the problem linked to GHG emissions, because biomethane is much less intensive in carbon than LNG from fossil natural gas. So you're right on the paper, but biomethane production is really tiny today. And considering, for instance, the roadmap for decarbonization in France, most of the biomethane which could be produced in France, and this is and the prospects are really high, with about, I would say, 200 terawatt-hours in 2040. This is half the consumption of today, and if we manage to do that, applications will mainly be in the industry and for buildings, for heating of buildings, and for application in industry, and there won't be a lot for transportation, and so this is probably not something that is on track today, but theoretically it could work, of course. Just 2 minutes to go, and we have more than 50 questions, so it is difficult to make a choice. I'm trying to detect a question on a topic we didn't talk at all. The energy can be transitional.
Well, there's a question on the impact of the SECA zone in the Mediterranean Sea. Well, SECA stands for sulfur emission controlled area. Therefore, to some extent, it has nothing to do with greenhouse gas emission. It's something really different. For the moment, the emission controlled area are dealing mainly with sulfur and nitrogen oxides, meaning SECA and NECA, but no regulations are set for carbon oxide or for greenhouse gases so far.
I'm trying to answer the last one about carbon tax, which posed the issue of harmonizing the rules on land and seas. And this is a typical recurrent question, and not only for maritime sector, this is the same kind of questions for aviation sector, both being very international, of course. And this is very clear that as long as countries from the different continents won't find agreements or just not unambitious agreements that will set some hurdles for transition. That's right, but it doesn't mean that companies don't have to anticipate the move, because the move will come sooner or later. It will come, and so companies, in our opinion, have to anticipate these changes, and they have to seize the opportunities that these changes are going to provoke on the value chain of transport. And for us, this is very important that initiatives emerge, even though governments and IMO don't move forward fast enough. Well, we would like to thank you for your participation. Many thanks for all the questions. We are very sorry that we didn't manage to answer all of them. We can confirm that we will send to all participants the presentation and also the recording of the webinar. And we hope that this was very instructive for you. And you don't hesitate to ask some more questions after the webinar if you like, of course. Thank you very much, and see you soon. Bye.
Bye.